95% of the universe is missing. Not hiding, not sitting in some galaxy too far to reach. Missing, as in, we can feel it dragging on entire galaxies. We can weigh it, and not one scientist alive can tell you what it's actually made of. Everything you have ever seen, touched, tasted, or posted online, every star, every planet, every atom in your body, adds up to a grand total of 5% of what's out there. The other 95% is a stranger in a cosmic trench coat, and that stranger is quietly running the entire show. Here's why you should stick around. The universe you met in school, the one packed with glowing galaxies and tidy little planets, turns out to be the foam on top of a drink you can't even see. By the end of this, the most solid thing in your life, the chair you're sitting on, is going to feel like a rounding error. Ready? Let's go to the crime scene. Back in 1933, a brilliant and famously grumpy Swiss astronomer named Fritz Zwicky was squinting at a swarm of galaxies called the Coma Cluster. He measured how fast they were zipping around each other, and something was very wrong. They were moving so fast that the cluster should have flung itself apart, like a merry-go-round spinning so hard the kids go flying. But it wasn't flying apart. Something was holding it together, something with a lot of gravity that gave off no light at all. Zwicky did the math and realized there had to be a huge amount of invisible mass hiding in there. He called it dunkle materie, dark matter. And how did the scientific world respond to this genius insight? It ignored him for about 40 years. Partly because the idea sounded absurd, and partly, let's be honest, because Zwicky was the kind of man who called colleagues he disliked spherical bastards, meaning they were bastards no matter which angle you looked at them from. History remembers his physics. It also remembers the insults. Would you have believed him? The person who finally forced everyone to take dark matter seriously was an astronomer named Vera Rubin in the 1970s. Rubin studied how galaxies spin, and she found the same ghost, just wearing a different outfit. Think about our solar system. The planets close to the sun orbit fast, and the ones far out crawl slowly because the sun's gravity gets weaker with distance. That's the rule. Rubin expected stars at the edge of a galaxy to crawl the same way. Instead, they were racing around just as fast as the stars near the center. It made no sense unless the galaxy was wrapped in a gigantic, invisible halo of extra mass, pulling on those outer stars. Here's the image that should stick with you. It's as if a merry-go-round kept spinning at full speed even after you yanked the entire platform out from under it. Something you can't see is doing the work. So naturally the next question is, fine, what is this stuff? And this is where it gets genuinely spooky. We check the obvious suspects. Is it just dim clouds of normal gas? No. Burnout stars? No. A pile of black holes? No, not enough of them. Dark matter isn't dark like a black shirt is dark. It's dark like it barely acknowledges the rest of reality exists. It gives off no light, absorbs no light, and mostly refuses to bump into anything. In fact, billions of dark matter particles are very likely streaming through your body right this second, and you're the ghost of them. They sail straight through like you're not even there. Physicists have buried gigantic detectors deep in old mines, sitting in the dark for years, basically waiting for a single dark matter particle to trip and fall into the sensor. And after decades of waiting, almost nothing. The universe's most abundant matter has never once been caught red-handed. Doesn't that bother you a little? Now, if the story stopped here, it would already be humbling. But dark matter was only half the missing universe. The other half is weirder, and it arrived in the most dramatic way possible. Fast forward to 1998. Two rival teams of astronomers, led by Saul Perlmutter, Brian Schmidt, and Adam Rees, were doing something clever. They were tracking exploding stars called type I supernovae, which all blow up with almost exactly the same brightness. That makes them perfect cosmic mile markers. Measure how dim one looks, and you know how far away it is. The teams wanted to measure how quickly the universe's expansion was slowing down. Because everyone knew it had to be slowing down, right? All that gravity from all that matter should be gently pulling the brakes on a universe, like a ball thrown up in the air losing speed. Except the data said the exact opposite. The distant supernovae were dimmer than they should be. The universe wasn't slowing down. It was speeding up. The expansion of space is accelerating, getting faster every single year, as if someone is stomping the gas pedal on reality itself. Both teams found it. Both teams basically didn't believe their own results at first. And in 2011, they got a Nobel Prize for it. Gravity told the universe to slow down, and the universe looked gravity dead in the eye and said, "Make me. Whatever is pushing space apart." We named it dark energy, and honestly, dark energy is less a real explanation and more a very confident-sounding label for "we have absolutely no idea." It's a kind of pressure woven into empty space itself. The emptier and bigger the universe gets, the more of it there is and the harder it pushes. Empty space, it turns out, is not empty and not resting. It's shoving. So let's do the final accounting. Thanks to a space telescope called Planck, which mapped the leftover glow of the Big Bang with stunning precision, the universe breaks down like this: about 68% dark energy, about 27% dark matter, and roughly 5% ordinary matter. That 5% is everything. You, your family, your phone, the sun, and every galaxy in every jaw-dropping telescope photo humanity has ever taken. All of the cosmos you can actually see is the rounding error. We built entire religions, sciences, and love songs about the 5%, and we didn't even know the other 95 was in the room. And here's the part that turns this from a fun fact into your problem. Dark energy is the thing that decides how the whole story ends. If it keeps winning, and right now it's winning easily, it will keep stretching space wider and wider until galaxies are torn so far apart that their light can never reach each other again. Trillions of years from now, the night sky of some future world could be completely, perfectly black, with no other galaxies visible at all. They'll look up and conclude they're alone in a tiny universe, and the evidence that they're wrong will have already vanished over the horizon. Scientists call this slow, cold, ending the big freeze. Kind of makes your Monday feel manageable, doesn't it? So the next time somebody tells you to be realistic, to focus on what's actually there on the real world, on solid facts, you can smile a little. Because what's actually there, the entire visible universe, is the 5% we barely understand. The realest, heaviest, most powerful thing in existence is the 95% that nobody on this planet can name. It's holding the galaxies together. It's ripping the cosmos apart. And it's passing through you right now. So what do you think is hiding in the dark?